Welcome to the section 21 of the course of Expert System with C++ and Qt. My name is Carlos and I'm going to have a review of the concepts of cubes and closures. In our Expert System, it might not be that efficient to have rules of atomic operands in our knowledge base. For example, A implies B, C implies D, D implies F, and so on. So we can infer a lot of things in a single rule. For example, instead of having a rule such as black, I will avoid parentheses. Smoke implies failure in combustion. We can have something more complex such as black smoke no power in high revolutions implies dirty spark plugs and high consumption of gasoline and remaining in cylinders and high CO2. But moreover of this, we can infer in these complex rules in a quicker and more efficient way. To do so, we need to follow structure rules. Actually, this is a structure rule, but I will explain it in detail. Okay, so for example, let's see this rule. In the inference kernel, we will call the left side of the operand, because we have a main operation that is the implication. The left part of this is called the antecedent, and the right part of this is the consequence, are the consequence. So let's see that all the cases if the antecedents are true, and by using the modus ponens rule, then all the consequences will be true. And any conjunction operation needs to have all its values to be true. For example, this must be true, all of them, to make all the consequence or the concept or the part of consequence be true. Okay, this operation can be very recursive and might be extended predictive. It depends on the amount or consequence of the antecedent that you will have. So if you put any other operation time, you won't be able to infer that easily. If for example I said something, I add another thing between turn off after 15 minutes. Using this antecedent with a disjunction operation, it might not work because you know that an AND has a 0, 0, 0, 0, 1, 0, 1, 0, 0, and 1, 1 is 1. This is the reason that this part, if all the antecedents without, having this as an AND, if all these guys are 1, the whole will be 1, and we can infer by modus ponens that the consequences are also 1. But if in the case that instead of using the conjunction I use the disjunction, you know the OR is different, because if any of these operands is 1, it will become 1. So in this part, imagine that these guys, the first one is 0 and this is 1. I think that Okay, whatever. Here. Imagine that this is 1. The second is 0 and the third is 1. But even though we are having a 1 as a whole, because the result of this OR is 1 even though this is 0. Okay? Then let me just put it. This kind of structure rules are called cubes, and I will type this correct definition. It's formal definition. It might be 0, A0, and A1, and E2, and A3, and so on until AN with its respective parentheses. Okay. Implies pretty much the same structure. In the cubes, the antecedents and the consequence are has the same structure, but to be formal, instead of A, we will put them B. So as a whole, this is 1. By modus ponens, we infer that these guys are 1. So if A is equal to 1, then A0, B0 should be 1. B1, 1. B2, value 1, and so on. So let's follow this quick example. Imagine that we have our rule base, our knowledge base as A implies B and C. B implies D. B and D. No. It's B implies D. The conjunction of D and B implies C and F with G and S. 1, 2, 3. Okay. And 4. The main one. So if the implicit knowledge has A with true value, then we infer in the first rule that B and C are true. The second rule, D is true because B has true already. The value true. Then because D and B are true, C, F, G, and S are true also. See, we already have it, but F, G, and C true. Okay. Let's mention also that if any antecedent has a value or has a false value, this rule cannot be solved now, because we need all the antecedents to be true to infer to the consequence, right? Next concept is closures. Those, instead of using modus ponens, they use modus tollens. And if there is a way to infer antecedents by the consequence value. So if all the consequences are false, then by modus tollens we can actually say that all the antecedents are false by following this structure. Pretty much the same, but instead of having a conjunctions operation with this whole antecedent, we might have disjunctions, all of them. This is the formal description or a closure. As I say, pay attention that the antecedents are using the OR operation. So for example, I put an example. Brakes are okay, and or ABS system is okay. Implies that no loud noise when stopping, power in slowing car, and no streaky disc. If all the consequences are false, meaning that we have low noise, no power, and a streaky disc, means that we need to have a service to the brackets, meaning also that the ABS is not okay and the brackets are not okay. So to conclude, it's important to have or to use as much as possible cubes and closures in our knowledge base, because in this way our system will be very fast and efficient. This is the end of the video. In the next one we will learn about how to use algorithms, how to use some algorithms that we are going to use in our infer kernel. Share up, vote, and comment in this video, and have a look to our website, Gear Text. Thanks.